I'm Ian Breitner from the Storage Solutions team at Dell Technologies, and thanks for joining. Today we're going to talk about edge computing and how that's going to impact application modernization plans. Now, everyone's heard of the 5 Ws. Perhaps they may be more familiar this way. We'll go through each of these in turn, and the order in which we may do them will make sense to me, perhaps not to you. So let's start with the what. What exactly is edge computing? Edge computing is defined by processing data at or near the source of the data. It is essentially a distributed computing environment. Data volume is growing, and IDC estimates that in 5 years there will be about 79 zettabytes of data from roughly 42 billion devices. As the volume and velocity of data increases, so too does the inefficiency of streaming all this information to a cloud or data center for processing. Edge solutions are designed to complement data center and cloud services. Edge computing serves as the decentralized extension of the campus network or cellular networks or data center networks or even the cloud. Santosh Rao from Gartner says, organizations that have embarked on a digital business journey have realized that a more decentralized approach is required to address digital business infrastructure requirements. So here's a simpler architectural view. Both cloud and data center have a part to play, but we now have a need to service new devices by delivering compute power close to the device itself. And those devices are proliferating at a great rate. And spoiler alert, it's not just compute power that's needed, but networking and storage as well. So why? We've defined edge as bringing compute in proximity to the source of the data. Edge computing is designed to complement existing public cloud, data center, or co-location deployments, and edge data centers offer advantages that none of these possess. It's due to the compute proximity to the data that is the core strength of edge computing. Its ability to support applications that demand a significant amount of bandwidth, require rapid response times, are latency sensitive, or any combination of them. And network traffic performance is much less of an issue at an edge location than with a data center or co-location deployment, or even the public cloud. In these latter cases, data needs to be moved from the location where it is acquired to a central location for processing. Doing so incurs latency. We still have not been able to communicate significantly faster than the speed of light. But across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partner. And this is kind of interesting. The movement to edge computing parallels the cyclical nature of IT trends. What began with centralized mainframes eventually moved to a decentralized approach with client-server networks. Then, the meteoric rise of the public cloud shifted computing back towards a centralized approach, only to have the recent rise in popularity of hybrid cloud deployments move the needle back towards a decentralized model. So when is this need for edge computing going to occur? The news, good or bad, is that it is occurring now. In fact, it started back in 2009 when Carnegie Mellon University used the term cloudlet to describe a micro data center, basically an edge data center. However, it was not until 2016 when edge deployments really started. Gartner estimated that only 10% of data was processed outside of the data center and cloud back in 2015. But now they estimate that within 5 years, the amount of data processed outside of a traditional data center or cloud will be 75%. This growth is basically due to IoT devices. These include mobile devices that we all use daily, like cell phones and GPS location services and so on. And they include new data sources, IoT devices that are being deployed in a variety of locations: vehicles, personal healthcare, hospitals and clinics, smart cities, retail locations, aircraft, ships, manufacturing, and so on. Growth rates for edge computing are estimated by analysts to be from 11% to 12% compound annual growth rate. And this might well be a conservative estimate. Those smart thermostats, smart utility meters, ever-growing mobile devices with specialized apps are only adding to the data that is being generated. You can see from this chart that the growth of the edge is growing exponentially, and we are here in 2020. So the Who, no, not the band. Who is looking to use edge computing? The number of use cases is still increasing, but common ones include supporting advanced Internet of Things appliances and augmented reality applications. So, for example, retailers can leverage AR to improve customer experiences by creating apps that help customers find their way around shops, implement networked smart mirrors to try on clothes without a changing room, or run personalized promotions and offers that leverage the consumer's historical purchases and personal tastes. Within manufacturing environments, artificial intelligence can be used for predictive maintenance of expensive machinery, drive down long-term maintenance costs, and significantly reduce the risk of failure. Elsewhere, raw input from IoT sensors can be leveraged for quality control or to reduce wastage. Edge computing solutions can take many forms. They can be mobile in a vehicle or smartphone. They can be static, that is part of a building management solution, manufacturing plant, or an offshore oil rig. Or they can be a combination, such as in hospitals or other medical settings. A wearable health monitor is an example of a basic edge solution. It can locally analyze data like heart rate or sleep patterns and provide recommendations without a frequent need to connect back to a main data center or cloud. The capabilities of edge computing solutions range from basic event filtering to complex event processing. By 2024, edge data centers are projected to exceed $13 billion, with the IT and telecom sectors driving growth. Manufacturers in the edge data center market are providing several effective solutions that allow businesses to adopt edge computing technologies for managing their enterprise data. For instance, Dell Technologies, my employer, is several computing solutions such as PowerEdge, XR2, R740, and R740XD servers that are optimized for mobile virtual network functions. But they also have a new offering, PowerStore, a storage array that not only can scale up and scale out, but can also run virtualized applications on the array itself. PowerStore natively runs ESXi. The management of the storage is handled in a VM, and the array can run user VMs. It appears in a vCenter as another VMware host and acts as with any vSphere host. It is highly redundant with dual controllers, servers if you like, which act cooperatively in managing the storage. The value this brings to edge computing is significant. Not only can PowerStore be used to house the data collected at the edge, it can also run applications that can process that data. And it does this in a very small 2RU form factor, about 3.5 inches high. And if this is of interest, I would encourage you to join Marco Abella's VMworld session on PowerStore or Heather Hitchcock's session on healthcare, where she talks about automating an ICU. So the where. Edge servers can form clusters or micro data centers where more computing power is needed locally. And they can be anywhere. And in fact, they are already everywhere. More complex edge computing solutions can act as gateways. In a vehicle, for example, an edge solution may aggregate local data from traffic signals, GPS devices, and other vehicles, proximity sensors, and so on, and process this information locally to improve safety or navigation. More complex still are edge servers, such as those that are currently being deployed in the next generation, that is 5G mobile communication networks. And these will host applications and cache content for local subscribers. So from connected vehicles to intelligent bots on the factory floor, the amount of data from devices being generated in our world is higher than ever before. Yet most of this IoT data is not exploited or used at all. For example, a McKinsey & Company study a few years back found that an offshore oil rig generates data from 30,000 sensors, but less than 1% of that data is currently used to make decisions. The edge is a focus area of burgeoning distributed computing framework, which is being created due to the latency and bandwidth requirements for new use cases. According to IDC's 2019 Data Center Operational Survey, 79% of United States-based organizations were planning to deploy more IT services at edge locations. Supporting new digital services at scale across many locations requires the ability to deploy and maintain infrastructure and enable connectivity in many locations. Organizations will be challenged to support connectivity needed for physical and data security in these locations. And real estate will play an increasingly role in edge deployments. For example, Walmart is exploring ways to rent out edge computing, leveraging its retail footprint. Retailers have the locations to enable edge computing. And there are several risks inherent in edge computing. So across all industries, the digital transformation of products and processes is creating new ways to connect with the customer and partners. Much of this innovation depends upon having IT service in new locations, that is, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of these investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail location or a remote site. It means the ability to overcome the variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms organizations. Evaluating, deploying, and operating Yes, I can. Already. So there are risks associated with edge computing. Across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partners. Much of this innovation depends upon having IT service in new locations, that is to say, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of those investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail or remote site. It means the ability to overcome variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms will strain the capabilities of even the most advanced IT organizations. Small problems will become magnified as the scaling increases exponentially. The impact could result in service interruption at best or security breach at worst. As with all rapidly evolving technologies, evaluating, deploying, and operating edge computing solutions has its risks, and they come in many forms, but a key one relates to security. Extending your footprint using edge computing exponentially increases the surface area for attacks. Unsecure endpoints are already used in distributed denial of service attacks or as entry points to core networks. And another concern is that the cost of deploying and managing an edge computing environment can easily exceed the project's financial benefits. Moreover, projects can become victims of their own success. Scalability can become a serious issue as new IoT endpoints proliferate. And of course, there are additional challenges. Network resiliency. While within the edge location this is not an issue, there is still the need to move data sets back to the core, either for additional processing or for archival. Then there's scaling the number of edge locations can be challenging, as noted earlier. Bandwidth and spectrum constraints, and we expect that 5G will alleviate some of these. Another good one is data sovereignty and its application in the EU to collect the data. And this may well extend to other countries, such as Canada and the US. Also, procurement is shifting from CapEx-centric to OpEx-centric. Organizations may not want to own the infrastructure they use, but rather rent it. And then system complexity as the edge expands it becomes more and more complex, and there are more complex interactions required. Remember this diagram? This only has 50 devices in it. What happens when you end up with tens of thousands? And not to forget the shortage of skilled labor resources. Organizations are struggling with their cloud initiatives, and Edge adds the need for a different skill set, which are even harder to find. Edge computing does help you unlock the potential of the vast untapped data that's created by connected devices. You can uncover new business opportunities, increase operational efficiency, and provide faster, more reliable and consistent experiences for your customers. The best edge computing models can help you accelerate performance by analyzing data locally. A well-considered approach to edge computing can keep workloads up to date according to predefined policies and can help maintain privacy, and will also help adhere to data residency laws and regulations. Developing a successful edge strategy requires taking into consideration the complexity of management endpoints and recognizing that scale and variability is dramatically different from traditional on-premises or public cloud deployments. And with that, I end my talk, and thank you for listening.